How semiconductors help to achieve net zero? Can you guess how much of the UK's electricity generated in 2023 came from wind turbines? 10, 30, or 50%? The correct answer is 30%. Wind-generated electricity has increased over the past decade, as UK has started to utilize its huge potential for wind power. Some of the world's largest offshore wind farms are located in the North Sea. Most people know that wind turbine blades catch the wind. The turning blades rotate magnets inside an electrical generator, converting wind power into electrical power. But did you also know that wind power generation relies on semiconductor technology? Semiconductors are the building blocks of computers and all other electronic devices. Semiconductor diodes and transistors also make up the essential power conversion circuits between the electrical generator and the grid. These circuits ensure that wind-generated electrical power meets the requirements of the power grid, for example, the magnitude and frequency. Conversion circuits use power semiconductors. These devices need to withstand high powers, thousands of volts and hundreds of amperes, which are quite different from the semiconductors operating at just a few volts, such as in memory chips or microprocessors. To increase the amount of electrical energy produced by each wind turbine, we can utilize the higher and more consistent wind speed offshore compared to onshore. Also, the newer wind turbines tend to be taller and larger, increasing the electrical energy they produce. However, these changes require the power semiconductors in the conversion circuits to withstand higher power than before. Another globally important renewable source, solar energy, is also heavily dependent on semiconductors. Solar panels are made from semiconductors that use the photovoltaic PV effect. The UK has an ambition of a fivefold increase in solar energy generated between 2023 and 2035, enough to power around 20 million homes. Each PV panel is made out of many identical PV cells. They are made from silicon, the most widely used semiconductor material. When sunlight falls on a PV cell, the energy from the sunlight is absorbed by the silicon, producing moving electrical charges and hence electrical power. Stronger sunlight produces more electrical power, but PV cells still produce power even on cloudy days, making them a viable renewable source for the UK. Each PV cell produces only a small amount of electrical power, but joining many cells together to form a panel increases the total power generated. Therefore, installing several panels on a domestic roof can often produce sufficient power for most households. Semiconductor technology has played a significant role in increasing electricity generation using renewable sources in the UK and globally. Increased contributions of UK-based renewable sources has already reduced our reliance on electricity produced by burning fossil fuels. This not only makes our energy production more sustainable, but has also improved our energy security.